For week 8, I had problem 46, and in problem 46, two wires are tied to the 300-gram sphere shown below. The sphere revolves in a horizontal circle at a constant speed of 7.5 meters per second. What is the tension in each of the wires? And so here you can see in figure 1, I've just drawn a little illustration of what's happening. And so over here we have the 300-gram sphere, and then it is attached to a rod with two strings, and then we see here the rod is revolving. And then in figure 2, I have added the forces that the sphere is experiencing. And so here you can see we have the tension caused by the top string, this is T1, and tension caused by the bottom string in T2. For the remainder of the problem, T1 will be referring to the top string and T2 will be referring to the bottom string, or the bottom wire. And then the sphere also experiences tension in both the horizontal and vertical axes, and so those are given by T1 and T2 times sine for the vertical axis and T1 and T2 times cosine for the horizontal axes. And then here, this little dashed line is our radius. And so moving on to important concepts, concepts important to this problem are Newton's second law and then obviously circular motion as well. Specifically in Newton's second law, we will be using this equation where the summation of the force is equal to mass times volume squared over the radius. And so we need to solve, and so moving on to our solution, we need to solve for the tension in both directions. And so to start, we have the horizontal axes and our force is tension. So we have T1 times cosine plus T2 cosine equals mass times velocity squared over r. And we want to rewrite this to get T1 and T2 on their own. And when we do this, we have T1 plus T2 equals mass times velocity squared over r times cosine theta. And then for our vertical axes, we have T1 sine theta minus T2 sine theta is equal to mass times gravity, and it's also important to remember that in our vertical axes, forces have to equal 0, so we include the 0. And when we rewrite this equation, we get T1 minus T2 equals mass times gravity over sine theta. And so next, in order to move on, we need to solve for r. And to do so, we will be using Pythagorean theorem and this triangle. And using Pythagorean's theorem, we can find that r is equal to 0.866 meters. And so now that we have a radius, we can solve for the tension in the horizontal axes. And so we plug in everything we know, we get that T1 plus T2 is equal to 22.5 newtons. And when we do the same for the vertical axis, we get T1 minus T2 is equal to 5.88. And so to solve for T1 and T2, we need to solve this system of equations here. And so you can start with either equation, but I decided to rearrange this bottom equation to solve for T1. And so now we have T1 is equal to 5.88 plus T2. And we will plug that into the equation above it. And as you can see here, when we do that, we then simplify and can solve for T2, and we find that T2 is equal to 8.31 newtons. And now that we have a value for T2, we can plug it back into our kind of initial rearranged equation and solve for T1. And when we do that down here, we get that T1 is equal to 14.19 newtons. And so our final answer is the tension in the top wire is 14.19 newtons, and the tension in the bottom wire is 8.31 newtons.